Hey everyone, this is Sindhu. Welcome back to my YouTube channel. Today we'll start this video with the topic how does the loading effect impact input impedance? The introduction part. This presentation explores the impact of the loading effect on the input impedance of a common emitter amplifier circuit. We will derive the equations for input impedance, analyze the factors that affect it, and discuss its practical applications. Input impedance and the loading effect. The input impedance is a measure of the resistance that circuit presents to the input signal source. Loading effect occurs when the input impedance of the circuit affects the signal source output, altering its signal characteristics. Let's see the equations of for the input impedance and input resistance. Input resistance is determined by the base emitter junctions characteristics and the base bias resistors. AC current gain. The AC current gain relates the base current to the collector current, significantly influencing the input impedance. Equations for input impedance. The input impedance is the product of the input's resistance and highlighting the impact of a current gain. AC equivalent circuit and input impedance. AC equivalent circuit focuses on the signal's impact, replacing DC components with their AC equivalents. Input impedance in a AC circuit. The AC's equivalent circuit simplifies analysis, focusing on the signal's behavior and highlighting the input impedance. Impact on a signal. The AC circuit reveals how input impedance affects signal strength and overall amplifying performance. Factors influencing input impedance. Base resistor. The base resistor directly affects the input resistance, increasing impedance with increasing base resistor. Transistor gain. The AC current gain plays a crucial role as the input impedance increases with the current gain, making amplification more effective. Frequency response. The frequency response of the input signal can also influence input impedance, particularly at higher frequencies where capacitor becomes significant. Impedance matching and circuit design. Impedance matching occurs when source impedance is equal to the input impedance, maximizing power transfer. Signal loss. Impedance mismatch leads to signal loss, reducing amplifier efficiency and distorting the output signal. Optimal performance. Proper impedance matching ensures optimal signal transfer and the most efficient operation of the amplifier. Minimizing loading effect on input impedance. Buffer amplifier. The buffer amplifier with a high input impedance isolates the signal source, minimizing the loading effect. Source impedance reduction. Reducing the source impedance by selecting a low impedance source can minimize the impact on the input impedance. Negative feedback. Negative feedback can stabilize the circuit, reducing the impact of a loading on the input impedance. Analyzing impact on circuit performance. First one is gain. So input impedance directly affect amplifier gain with the lower impedance leading the reducing gain. Second one is bandwidth. Input impedance affect bandwidth as higher impedance can lead to reduced bandwidth. Distortion. Loading can introduce distortion, particularly if the input mismatch is significant. Fourth one is power transfer. Impedance matching maximize transfer is leading to a more efficient amplifier. These are some practical applications. Conclusion of this topic is understanding input impedance and its relationship to loading is crucial for designing effective and efficient C amplifier circuit. This analysis helps optimize circuit performance, ensuring optimal signal transfer and amplification. Thank you.